Hey guys, welcome to our next session. We have Dan, CEO of TrailBits, and Stefan, practice lead at TrailBits. They'll be doing a talk around security success stories in DeFi, and I'll let them take it from here.
Great. Hello, everybody. I can't tell who's out there and who's not, but I assume there's somebody, and I'm not talking to an empty room. So I'm Dan Guido, CEO of TrailBits, and I've got my colleague here with me, Stefan Edwards.
Hey,
Stefan,
everyone.
say hello. Yeah.
There we go.
Today we've got a really interesting set of information to provide to all of you. I wanted to walk through kind of what a security review looks like, what it looks like to work with a security vendor from the top down, since there seems to be a little bit of widespread. Did somebody hide my video? Yes, they did. Okay, great. Thanks for doing that. So I wanted to share some stories of what it's like to actually work with a security firm, kind of what kinds of problems that we're able to solve and how solving them looks for the people that receive that information. So let's just move this forward. So if you don't know who we are, TrailBits is a software security research and development firm. We focus on a pretty wide range of security problems. We have a research team that works with DoD and DARPA to do foundational research in computer science, usually in the fields of automated program analysis and cryptography. We have a security engineering team. People hire us to write software, usually high assurance software or security tools. We have a lot of open source code that we maintain. About a third of the company is shipping software every day. And then people hire us to do security assessments, product security reviews. They give us access to their source code. We assess the current state of it and help them get on a path to improving it. We do this in the blockchain space, as well as many other areas in the technology, finance, and defense industry. Like you may have heard that we're currently working with Zoom to improve the security of their clients right now. So today, I wanted to share this portion of a larger deck that we have, digging into a few case studies of working with blockchain firms. So we're going to go through two case studies of two very specific DeFi applications that we've worked with, where they came to us with a certain set of problems. We evaluated what those problems were, came up with an assessment approach to mitigate the risk as best as possible. I'll share what we found and some of the lessons that we were able to learn and that our clients were able to learn by going through the process with us. At the end of this deck, we'll also share some references and advice that we think everyone can take away from these projects and the kind of security knowledge that we've been able to learn. So one real key thing that I think is important to understand here is I'm not going to focus just on on-chain risk, since DeFi applications really incorporate a lot of different components to build a fully functional product. Many of our projects involve off-chain components as much as they do on-chain components, and it's important to investigate the security of both and further how they kind of integrate and communicate and collaborate together. We will start with one that's a little bit more off-chain focused.
Yeah, I think the other interesting thing too is that we know how to test things on blockchain. Dan has another talk that I think is titled "What Blockchain Got Right," and we can do many techniques such as symbolic execution. We can do all sorts of like interesting abstract interpretation problems, those sorts of things for on-chain components. But off-chain components are really this sort of gray area where you have all of the problems and all of the concerns that you have for on-chain components, but then all of the traditional intricacies of InfoSec as well. So it's like a doubly hard problem because you have both sides of the coin there as well. So it's been interesting for us to get into this space.
Awesome. So the very first company that we'd like to profile is Compound. And I'm sure that most people are familiar with Compound, especially if you're at a DeFi conference. But they've become extraordinarily important over time. Really a major player in the space. There's a lot of eyeballs looking at what they do, and we've been working with them for a number of, I guess, years at this point to help them understand some of the risks that they currently have and the things they can do to address those risks. So let's talk through a little bit about what they came to us with. And Stefan, I think you can probably lead this better than I can, since you actually worked on this project.
Yeah, Compound was an interesting one, right? They came to us obviously with their smart contracts. They needed some background and some checks on them. And if you've ever looked at Compound's code, they do have an interesting style. So it wasn't the sort of normal, safe math libraries and those sorts of things. They do some very interesting and novel things with their code itself. But I think the other interesting thing is that Compound was one of the first clients that came to us and was actually specifically concerned about their off-chain components. And they were concerned about correct interactions with oracular components, with components that they relied upon that were hosted and owned by third parties, those sorts of things. So they were really interested in the correctness of their on-chain items. They were very interested in their oracular components and if they were working correctly. And then if the entire gestalt worked the way that they expected it to. So it was very interesting, and it took us from Solidity semantics to how EVM does things to economic concerns there, all the way through to like how are we hosting keys in Kubernetes, and what are the like regulatory and policy concerns that we as an organization may face. So it was an extremely fascinating set of projects that we've done with Compound, and we've worked quite deeply with them across the entire space.
Excellent. So we were able to pull a bunch of kind of approaches out of our tool belt to start solving some of these problems. Like, how do we approach working with a client like this that has those kinds of concerns, Stefan?
Well, so in general, we follow something very similar to that diagram that's there. That diagram is from NIST 800-115. It's basically a process of really going through and planning for an assessment, and then using a feedback loop of things that you discover during, say, a threat model, or things that you discover from documentation or from code itself, or just really looking through the system and finding edge cases and interactions to feed back into further discovery and further reporting processes there. So we have this process of mapping the edges going from, say, Kubernetes or from Solidity functions, and then seeing how we can actually attack those with privilege escalation, man in the middle, et cetera, and then report on those whilst also feeding that back into our discovery process and going from there. And we do the same thing for architecture reviews as well. Start from the edges, work our way in, and effectively report everything, including gaps in controls and impactful areas that hit upon their threat model and the threat scenarios that we discussed with them.
Excellent. Okay, so what did we find? We went through this whole process. Now we've got some information we've discovered. What are the outputs of a process like this?
I think it was very interesting. When we were working with Compound, they actually did have fairly solid Solidity practices. They knew their code quite well. They really did go through and understand their processes from tests and the sorts of QA things that you would expect, all the way through to on-chain. Where they were really having more issues with was the sorts of like key exposures. Like, what do we do with all these keys that we have? How do we segment and separate out our network components? Or how do we do things like make sure that all of our oracles are receiving information from secure sources? So it was very interesting to work through and actually see how things can sort of break down when you're trying to do all the things within a normal like DeFi application or even traditional finance application here. So there's a lot of interesting things that came out of it, including the sorts of like traditional InfoSec findings, like you're missing network level access controls.
Excellent. Yeah, and I think the key thing to note here is that a lot of these issues or concerns or kind of tasks to improve, they don't get solved with blockchain technology. Like, they aren't on chain. You can't just apply Ethereum or Tendermint or like whatever and expect to have a system for managing your keys, or expect to have like a really solid governance system. So this is still like traditional InfoSec, and a lot of the same traditional InfoSec kind of methodologies as well as standardized advice all still apply. You have to get this stuff right. And that if you don't get your traditional InfoSec stuff right, it can sabotage the effectiveness of your perfectly secure on-chain stuff, right? Okay, so what are I guess I already got into some of the takeaways here, but yeah, Stefan, from your perspective, what were some of the lessons learned here from Compound's perspective and from ours?
I think the really interesting thing was this was our launching point for Kubernetes itself. We started from Compound. We started to see more and more customers asking us for advice on Kubernetes, for advice on how do we actually implement oracles and those sorts of things. But then we also started to get into like the operational guidance and what are the nuances and edge cases of operations that traditional InfoSec maybe doesn't have visibility into because they're not aware of what blockchain needs to do. So it was super fascinating to come up with all of the guidance around safe handling, safe hosts, cloud information, and automation there as well. And then also it was fascinating to see just how many ways we have not actually come up with decent handling for off-chain things, right? Very often we understand how blockchain works. We can work through how smart contracts work and whatnot. But there's all of these associated accoutrements that I don't think we very often think about when we're talking about our blockchain risk, such as where do I store the keys? Like, is it okay if a key is exposed in an environment variable in Kubernetes? Because that is how Kubernetes sometimes shares secrets depending on the type of secret you're using. So understanding all of the data flows and understanding all of understanding all of the components and how they interact can actually build up to a very interesting set of problems for traditional InfoSec as well as blockchain itself.
Great. Okay. And just to respond to a couple of questions that I see coming in, one of the things to note here, like, do I have a checklist or an audit protocol that I can share? The answer is not really no, I don't, because a lot of these issues are very application specific, and there isn't really a standardized methodology to say, secure all of your off-chain systems. It really requires a detailed understanding of what you've built, what you need to rely on, what kind of controls need to be implemented, and then assessing the quality of them. So it's while the on-chain stuff is a little bit more standardized, and I'll go through that in the next case study, the off-chain stuff is a lot more you need to be familiar with what you're building and work through all the issues around it.
And also to Eli's question around operational issues, Compound actually was concerned about quite a few of these things. We're not a quality assurance firm, we're a security firm. So we come in and help clients with operational issues and those sorts of things and help them understand maybe the full risk to things. But this was not something that was surprising per se. It was just, how do we do these sorts of things? They needed more of like a peer review for how to handle these sorts of things rather than like this being a complete surprise to them.
Yeah, exactly. Okay, great. Let's go through to the next case study. So a company that we'd like to talk about is OX. Again, another kind of decentralized finance application that is wildly important in the space and has really become a major player and also somewhat substantially complex over the time period that they've been around. So peer-to-peer exchange of assets in the Ethereum blockchain, right? I don't think I have to explain who they are. So with OX, the situation was much different. They were in a state of being surprised, where they had done a lot of security reviews in the past. They'd hired a whole bunch of security experts to investigate the code. And then Samsung shows up and drops ODE on whatever you've built, right? It's something that's commonly happened to people across the space. But people had the mistaken impression that, hey, because we hired all these experts and because they looked through all the code and because they found all these bugs and we fixed them, then why was this able to occur? So you're in a state of being surprised. You don't really have a holistic understanding of where your risk might be, but you know that you've invested a lot in identifying and squashing individual bugs. I think that's a state that many people in the blockchain are at because there isn't really good holistic guidance. People don't know exactly how to measure their own maturity because we don't exactly know what a fully mature blockchain system looks like at this point. Everyone's kind of figuring this out as we go. So I've got two little excerpts here down at the bottom. The one on the left is a copy of the blog that Sam wrote describing the security vulnerability. And then the excerpt on the right is the OX team's discussion about why they didn't find it. And it's really endemic of this kind of belief that, hey, if we just invest a whole lot in people finding bugs in our system, then that means it's going to be safe. So instead, what we did is, we were brought in and we could have approached it the same way. We could have said, okay, well, we're smarter and we've got better tools and we have more experience. We have all these research people. So like, clearly we're gonna be able to find more bugs than anybody else. We'll dig them up and like get them patched. But we tried to hold back and not do that. Instead, we wanted to provide more top-down kind of holistic guidance to OX about where hotspots were in the code base. Where did they have to plan a new project to invest in new security improvements? What best practices have they not yet adopted and they should? There's also an interest of how do we adopt formal verification, right? A lot of people in the blockchain community have used formal verification as a big buzzword of like, hey, this will just fix everything. But what does it actually look like? So what's the first step towards getting there? And then really gain like a strategic understanding of what do the next 3, 6, 12 months of security improvements to this code base look like? How do I improve my software development lifecycle so the next time that I write an iteration on top of the OX protocol, it comes out safer than the last one? So all these are real big challenges that even when you're working with security experts, you can find difficult to get out of them. So what did our approach look like? Stefan, why don't you talk through a little bit of the architecture risk assessment?
Sure. So this is something that's exploded in popularity. I've been doing threat modeling for almost 10 years now, and it's always been sort of a niche area. It's not something that people very often needed outside of certain government and finance applications. And so we generally haven't had many sorts of like forays into threat modeling until recently. And I think it's been picked up by distributed finance quite a bit. We've seen these sorts of discussions around some of the flash loan issues that have come out. But basically, the team went through, did a 1 week, very high focused assessment of how OX approaches things, looks through the actual architectural components, and then identified a set of controls that they felt could be improved or really, really could be strengthened across the architecture itself. So instead of looking at like, oh, this line of code is problematic, you go through and you talk with the developers, you talk with the team, and try to understand the flows as they intended them to work, and then see what the actual components have in terms of controls and in terms of mitigations for risks that you discover during this process itself. So it's a very fascinating process, but it's also very new for blockchain. So it's interesting to see. And then we have also been adding our own control family, because one of the questions was, do we recommend like NIST or those sorts of things? There are control families out there, but we have been attempting to adapt some of the things that we've seen from our security assessments for these sorts of architectural assessments, because there aren't all of those control families out there for things.
So you've got an example here of these 7 different control families that we've pulled out: access control, state machine, arithmetics. Like if you're building a decentralized finance application, you have to have extremely strong control of how you work with numbers, right? That is an important thing. So what we'll do is we'll look through the entire code base for how well do you deal with numbers, and then we can rate your control rating as you deal with numbers really well, you're strong, or you don't have really strong control of this particular area, so your controls are weak or adequate. And then the question becomes, well, how do we plan an improvement to our development process that elevates our maturity from weak to strong? And that's a more strategic look at security lifecycle than simply individually patching bugs. Now, the process, one last thing. So the process that we use for actually elevating these controls from weak to strong in many cases is something we call security property driven development, where we're trying to identify like what the code should do and write it down. There's usually an idea that exists in the developer's head. There's an idea that they've written down on documentation, and then there's an idea that they also have listed in code. All these things need to be consistent, and there needs to be an automated programmatic process that evaluates that every time you write a new piece of functionality. So we define what those security properties are, and then we use something called automated test generators, which are things like fuzzers or symbolic executors or abstract interpretation or whatever, in order to prove to the developer and prove to the owner of the system that, hey, these security properties, they hold. Stefan, were you gonna say something?
No.
Yeah.
No,
okay. Awesome.
That's spot on.
Covered it. All right. So, what is the process that we used? So this whole security property driven kind of security assessment and development is kind of difficult for some people to wrap their heads around. It's not something they typically teach in school. It's not something you'd have experience with if you were developing normal like enterprise software. It's really exploded in popularity around blockchain systems and smart contracts in particular. And it requires a little bit of knowledge of fundamental computer science to do well. So we've put together a training guide called Building Secure Contracts that includes our development guidelines for both adopting strong positions initially in all of these areas, as well as an introduction to more advanced usage of program analysis tools to do really detailed property-driven testing. So at Trail of Bits, we've built 3 tools for doing that. We've built Slither, Echidna, and Manticore, and all of them have different strengths and weaknesses when you use them to test a property. There's 2 components to a property, right? There's the property itself and then how you test it. So what you want to do is you want to use the cheapest, easiest, quickest method possible to test a property initially. And then over time, you increase the kind of coverage of the tool you're using to test that property. So you might start with static analysis, or you might start with fuzzing, but then over time you build up to symbolic execution, where symbolic execution might be a way that you can gain more perspective into the application and more assurance that your testing of the property is correct. So all this is documented and reviewed in this training that I highly suggest that we provide to our clients, that we try to walk them through in the span of an engagement with them. So that's building secure contracts. So what did we find? Results. So we worked with OX, and we did a detailed architectural review. We pulled out this maturity review of various contracts and their adoption of security controls in each one. So you can see they've got some asset proxy contracts. It was really important for them to have strong access controls. They did. That was great. But then there were other areas where we said, hey, we think there's some warning signs here. We'd like to investigate them further during a security review. We are going to work with the developers of that subcomponent, identify security properties that are important, encode them into a fuzzer, and then test for them. And this column on the right is exactly what that looks like. So up on the top is an echidna test for some type of arithmetic related issue, right? We're checking to make sure that the balance for something can't be under 1,000. This is completely arbitrary. It's not actually something we pulled out of OX. It's just a template. So with that test, though, we can use that to evaluate one of these security properties, and then we can tell you if you either passed or failed. Every time that you check in a new piece of code, the Echidna system will kind of automatically generate tests to see if it can violate that property. Can I make the balance go underneath 1,000? If I can, then it'll tell me how. It'll give me a sample trace and the inputs required to make it fail. So over the course of working with OX, we managed to pull out 135 of these security properties and wrote tests for all of them. So they went from 0 to 135 security properties. And now what you can do is most of these security properties are being tested with Echidna, which is a fuzzer, which is great, but it's fallible. Sometimes the fuzzer doesn't generate the input needed to violate the property. So instead, you can replace this later with Manticore, a symbolic executor, or you could replace it later with a different kind of verification tool that ultimately provides greater and greater coverage and greater assurance that the code works the way it should. Then obviously this last little kind of excerpt here down at the bottom, we also dug through the code base and found a bunch of bugs, right? So we found 23 issues. There were a lot of them related to the exchange contract. We fixed all them. It was great. But that box on the bottom right, that's usually where most security firms end. That's what many people in the blockchain industry are hiring for. They're hiring for somebody to be essentially, you know, what Eli was saying above, somebody that is doing QA. And that's great. Like that's the minimum bar. But if you want something more strategic and that gives you kind of a holistic understanding of where you are today and where you need to be tomorrow, then this process is more of what it looks like. So yeah, lessons learned. You need to think about security holistically, even when you're just looking at on-chain systems. On-chain systems have a lot of things that can go wrong. It is not a solved problem to build secure on-chain smart contract code. When you do that, you need to document security properties. It doesn't help you if all you're doing is ad hoc finding individual bugs. Having a smart brain look at a piece of code is only so good as that smart brain, essentially. And that's why a lot of people in the blockchain space keep hiring like half a dozen firms to look at the code from 10 different directions, when instead what they should do is they should approach it as a security property driven activity, because then they get measurable improvements. And those measurable assurances, like, you can rely on them. Like, you can rely on them insofar as the testing technique is capable of proving them.
And also, Dan, it's like you want to be able to take the human level specification. This is the business intent that we thought we had when we were designing these sorts of systems, and then be able to say, is this something that we can actually test in code? Yes or no? And if no, can we test close enough to that thing to actually get some understanding or some assurance of these sorts of things? So everything from design reviews through to specification reviews to actual property extraction, they all just really are meant to help you understand your system across all of your oracular and off-chain components, all the way through to smart contracts. So similar to how you might have echidna properties, or you might have Manticore tests, or whatever, Varex, or those sorts of like higher specification systems, whatever they are, it's really just extending those sorts of activities left in the continuum to make sure that you can catch any of these issues at the design phase, or maybe at the specification phase, rather than when it's on chain and now you're attempting to respond to an incident or respond to an edge case that you hadn't considered.
Great. So I see Stefan answering a few questions in the sidebar. This is actually part of a larger deck, and let me advance the slide one more. So this is part of a larger deck where we actually go through 2 additional case studies. The other 2 case studies are from the centralized finance world. I believe Paxos was one of them, and I can't remember the last one. But it's really important to learn from all these folks, because whether or not you're centralized or decentralized, we're all trying to solve many of the same security problems. And in particular, Stefan pointed out something like the NYCRR 500, aka the New York City bit license, as a key concern for many people operating in the we'll call it blockchain finance space. That prescribes kind of a minimum set of controls that you have to meet in order to board the ride, in order to play ball in New York City in the financial system.
No, New York State, Dan.
Oh, New York State. Oh, darn it.
It's from the Department of Financial Services in New York State. But it's basically, if you, like Dan said, if you want to ride the train, you have to have these sorts of controls in place, and it's a much simpler checklist. If folks have looked through some of the like operational security checklists that you see from other government institutions, these can be hundreds of pages. NIST 800-171 is a very large document if you've ever tried to work through those sorts of things, or even going through NIST cybersecurity framework. Whereas NYCRR 500 is I think 21 or 23 pages. It's a fairly simple checklist, and it's a good starting point. I wouldn't say it solves all operational security issues, but it does give you things that you can answer very simply in a checklist style that says, yep, I know how to do that, or, oh, hey, maybe we need to go through and see this sort of thing again there.
Great. Yeah, I got thrown off by that NYCRR.
Yes, everyone does. But it's New York codes, rules, and regulations, section 500.
Okay, well, so these are the takeaways from the larger deck. I didn't try to modify them to deal with the shortened version, but just to hype this again, the NYCRR 500 rules are really great. You should look at them. Whether or not you have to comply with it, you should. Traditional security is not dead. Like, there's still a lot of things that are off-chain, and there's lots of security problems that aren't solved by blockchain. So code, procedures, decisions all need expert review from security stakeholders and from folks like us. You really should understand at a high level the kind of risk you're inheriting when you build your system. Try to identify your business and application risk. Consider using techniques like rapid risk assessments to find that risk. We didn't really talk about that, but you can Google it. It's a great little technique that we employ frequently to identify areas of hidden risk. And then on-chain security is not a solved problem. Most people are approaching this ad hoc by finding individual bugs. What you really ought to do is follow the guidance in building secure contracts and make measurable outcomes by defining and testing security properties. So that is it. I'd love to take any questions you have in the time that we have left. And I will post a larger version of this online. We actually have a recording of the whole thing. It's 90 minutes, Stefan and I just bantering back and forth. But
as we
well
usually
worth
do.
well worth the read.
All right, guys, this was fantastic. We're going to have to transition to our next session. Is there any last words you want to mention?
If you want to keep up with us, follow us on Twitter, Trail of Bits. I'm D Guido. If you want to follow me personally, Stefan is Logical.
Yeah, I'll type it.
Yeah. But reach out to us if you need any help. We're always happy to help people. Just, we're always happy to help anybody. So just email us if you've got questions, and I'm happy to help point you to the right resource or give you guidance if I've got it already.
Okay, perfect. Thank you guys so much. We're transitioning now.
Thanks. Bye.